Hello everyone, I'm Dr. S. Uma Mageshwari, E&I Department of SRM IST. I welcome our Head of the Department, Dr. A. Vimla Juliet ma'am, faculties from other engineering colleges for this 3 days online FDP on Recent Technology 2020. Nearly we received more than 600 registration form. Among those, we have shortlisted to 300 participants. We have 3 different speakers for 3 days. On day 1, that is today, we have Dr. A. Atif Shah, founder and managing director of ABE Semiconductor Design, Chennai. On day 2, the speaker name is Mr. Vinod Venkateswaran, Senior Principal of Infosys Engineering Service, on the topic of practical implementation of IoT. And on day 3, we have speaker Dr. N. Balaji, Associate Professor, Department of IT, SSN College of Engineering. The topic is handshaking of cybersecurity and AI techniques. Thank you all for joining the session today. The topic of today's talk is a practical approach on machine learning. It will be a 1-hour session. It is a great pleasure to introduce our guest speaker, Dr. A. Atif Shah, founder and managing director of ABE Semiconductor Design, Chennai. He has published many papers in reputed journals, started as lecturer and now playing the role of chairman, technocrat, and most importantly, the combination of teacher and industrialist. The span of 15 years of journey, leading nearly 40 plus research teams across the nation, designed nearly 50 plus techno transfers, designed major products such as IoT-based dementia caregiving system. Thank you, Dr. Atif Shah, sir, to accept our greetings. Dear participants, we will circulate the attendance sheet randomly during the session. You have to fill the attendance sheet. And so now, Dr. Atif Shah, you're in the line, sir?
Yeah, yes, ma'am.
Can we start? Yeah.
Sure.
So now the online stage is here, sir. You can continue. Thank you.
Yeah, thank you. Very good evening to one and all here. And this is Dr. Atif Shah, Chairman and Managing Director of ABE Semiconductor Designs. And first of all, I want to have the word of appreciation to SRM University, that is the Department of Electronics and Communication, who have organized such a wonderful event on the virtual faculty development programs on recent technology. And it will be a pleasure for me to be the part of this, to deliver or share my experience on this kind of machine learning and artificial intelligence for 1 hour. Right? Thank you. Let me start the evening's program with the agenda, what I'm going to talk about today. So the first thing is about this is going to be like my solutions, because we are specialized in developing machine learning and deep learning, and moreover the artificial intelligence solutions for various domains actually. So I'm here to explain, and I'm here to share my experience and knowledge about how we developed it, what is the perspective of looking after the machine learning and deep learning algorithms over the designs. So this is my thing. And moreover, my session is going to be not running the PPTs. It is going to be a discussion panel. And whenever the block diagram or model is required, I just show you the PPT. So this is the kind of a thing what we have right now. So now we'll start with the basics of what we have, like artificial intelligence is. What is the artificial intelligence?
Sir,
yeah.
Sorry for the interruption. Please
Yes,
make it as a presentation mode, sir. Change your mode to presentation mode.
It is okay now?
Yes, sir. Fine, sir.
Yeah,
Thank
fine.
you.
So the logic is fine. We are going to have this kind of logic actually on the artificial intelligence program. So what we are going to do today is it is a myth that the artificial intelligence is only implemented for the robotics, but it is not so actually. So artificial intelligence plays everywhere. It plays its role in everywhere, every domain. So that domain has been now categorized, and we are going to apply with an example of an application, how it has been developed. So let me shortlist some of the hot areas where you are and where we want to find out the logic with the AI. So these are hot areas nowadays, like we have wireless sensor network, image processing, most importantly voice processing, and finally you can see the network analysis that we called as the integration with the sentimental analysis. So we have a lot of applications here with all the stuff actually. So let me have this one by one application, how the AI is going to apply for each and every field with relative with my COVID research. Okay, so with how we can relate it with the COVID research, that we can able to relate one by one. So first thing is about, so we'll start with basic fundamentals, right? The basic fundamentals comes here is, so what we have here is what we require for an AI and the machine learning algorithm. So first thing is about, you must be carefully noted down. So what is required for the AI? So AI needs a data model. Okay, so you need the data, and the data can be of any category. First thing is about it of any category. So it may be as we seen on the previous slide, it may be of sensor data, or it may be of your voice, it may be of your image or a video. So remember, we are working on the dynamic data model, not on the static data model. That is, everybody fix up with this sensors or a voice. That's not sure. We are working on the mixing of a dynamic data model, which can have a fusion of both the image as well as sensor, video as well as voice, anything. So data model is important for your AI. And here I like to make it with the COVID, because nowadays, like AI is, everybody is working on AI for COVID based devices. Now the COVID needs non-invasive technology. So now for the extracting of the data from the humans, we need a non-invasive. And here the IoT plays an important role. That is the Internet of Things. So we need an Internet of Things, that is a device which can able to extract the data and collect it in and put it up in my DBs, that is your databases. And finally, we need to extract the feature. That is very simple. We need a extraction of a feature. And from the extraction of a feature, I must go for the intelligent learning algorithm. And the intelligent algorithm has been fused, or it has been integrated with a decision box. So the decision box is important to decide what has to be happen. So this, hope you have understood what is this is the block diagram of all these concepts actually. So we'll repeat once again: data model, the dynamic fusion of data. That is, you have to fuse it, the image versus voice, and the sensor with the video. So these are all the fusion. Now we are working on the area of multiple fusion of data model. So we don't work on only single data. So that's why I'm thrusting out, because this is important, because multiple data model or multiple fused data model. So this model, after designing this model from getting the data from each and everything using IoT, video and everything, we need to go for a storage, and then I'll go for the feature extraction, which you are used to extract the features. And then there comes a logic of intelligent learning algorithm. So that makes the sense for us. It is an intelligent learning algorithm and fused with your decision box. So this is how your AI model works out. So whenever you take any research, whenever you take any model for design, this is the basic criteria of designing an intelligence-based system. So now what we can do with that, where to start with that? So we start with the modeling, how to model it. We'll come one by one with the application-wise inputs and application-wise feature extraction and everything. First, we'll just concentrate on the intelligent learning algorithm. So what do you mean by intelligent learning algorithm? So we are all the teachers, right? I'm also basically a teacher actually, and then from industry, actually industrialist. So we are all the teachers. What is the intelligent learning belongs to here is, so let us assume you are going to train the student, right? So we have a group of students, and the students will be of different categories. They will have the different categories and everything. And then what we do is, like, we fix up the mark for them to get it in. So what we do is, like, we have a percentage of marks or a good marks, whatever the threshold, we fix it up, we'll fix it up here. So what we do is, normally we do a lot of training to the students. Like what we do, like we do retests, we conduct tests simultaneously, assignments, whatever, like, and most importantly on the previous question banks and everything, we just do the training to the students, and ultimately we get the output. Getting output is a nightmare, but still assume you are getting an output actually, right? So what is the logic here? What is the logic? This intelligent learning, what it comes across here is, so every time, again, the data decides your intelligent learning. So what kind of data we have to process, and from which kind of data we have to process, that decides your model, because the data plays an important role, as we talked about earlier. So just keep in mind that we have a group of students of different calibers. If you have a bright student, no worry about the intelligent learning, we'll get it out. But if the students are mixed with a lot of pains, like a lot of capabilities, then we have to face a lot of mechanism. The model has to be chosen correctly so that we can hit the target. So here comes the intelligent learning algorithm. So this is where the learning comes into the picture. And we have made a two classification. As we know, it's a hot topic actually today. That's a machine learning and the deep learning logic. What is machine and deep? Both are used for a machine learning. Both is utilized for training the machines actually. So, but what happens here and what makes us to understand the logic here? The intelligent learning, what is the machine learning and deep learning? So machine learning has the subset of deep learning. So this is the logic. It has the subset of deep learning. So it's a categorization, and these both, without a learning, you cannot build an AI algorithm. So that's a logic. Okay, so machine learning and the deep learning. So let me draw a line of difference between these two. So it's a line of difference. It's not show that it is made it. So first thing is about a machine learning. You have to understand clearly that it depends upon data model. When the data sets are very small, when you have a very small data sets, I'm not saying that you are working only for the 5 data. It is not so. If you have very small data sets, then it is known to be your machine learning algorithm. It is known to be your machine learning algorithm. When you want to work on the small data set, design a learning model, we need to go for a machine learning. And the similar way, when you have a large kind of a data, large number of data, and you have to do a lot of applications over the large number of data, this is known to be a deep learning. So there may be a question, why can't I implement a deep learning over machine learning data? So what happens? At an example, let me have a 6th standard student. So 6th standard student data is there. They assume you have a 6th standard students, and you need to train them only for the 6th standard syllabus. Even you can increase up to 7th standard. That's all, right? If the student, or in another case, if for the candidate or a person is studying for a IAS examination, his syllabus will be different and his training mode will be different. I cannot impart this IAS syllabus on the 6th standard student. If I impart on him, what happens is there is a problem of overfitting. That is, there is the system, the performance of the system degrades. So what happens if you thrust on keep on making him to study with IAS examination, even 6th standard student, it is not possible. Even the engineering graduates like us, it is not possible. So you need something special care for them. So that makes the line of difference between your machine learning and your deep learning logic. So remember, you have a only small set of data which has been there, and with the help of that, I can able to integrate ML. And when you have a group of data which is large enough of data, we need to go for a deep learning. So hope you have understood the difference between these two. Second is, what are the subdivisions, subcategorizations? Even though you have another important point, we'll discuss with that, with another important point with that. So second thing is how to fix it. I'm talking about inputs and outputs. How to fix it up? So please remember, when you have like an input and outputs are known to you, then it is known to be a supervisory control. It's a basic thing. You have an input and output are fixed. In the case of, for example, what we have taken, the students are known and the output is known, but achieving the output is different. That is different, right? So we know what is the input and what is the output. So if we made it, we call this a supervisory learning. And unsupervisory is something like working on the inputs, right? So if you have inputs, group of inputs, I do like categorization and everything. But the special care should be given on the unsupervisory learning in terms of voice processing. I'll explain you when the voice comes into the picture. So this is the second criteria. And third criteria, we have the learning algorithm called reinforcement learning. Reinforcement learning is something which is primarily utilized in all my devices, robotics and everything. And we have a fourth categorization, which is most important. That is known to be self-adaptive learning algorithm. This is most mechanism and most advanced one for the machine learning or a deep learning is concerned. So we have the self-adaptive learning algorithm. What do you mean by self-adaptive? The word itself indicates you. Self-adaptive, it keeps on learning. I'll explain you, right? It keeps on learning. So this is the criteria where today we are working towards that, a self-learning adaptive mechanism. But what is the significance? Why? Because it's in all the cases, on all the case of subdivision, once it's trained, you will test it based on the group of data what you have. But here, what happens in the self-learning adaptive, if I train at once, it has to update its training data with the new inputs. So we'll talk about this later on, what is to be done. So these are all the four subdivisions, what we have in the learning algorithm. So now what we have to do is we are going to play a video for you. It's my favorite film actually from Endran. So we are going to look out for a 2 minutes clipping because we are going to have an explanation on this. And we are going to derive a model based on the perspective of machine learning and the deep learning. Okay. So let me have this actually. Yeah, hope you are seeing it actually. So hope you are seeing this film and hope you are seeing this video actually. What happens here is, so this is a scene of your what do you say, it is called a scene from the film. And then what happens here, just look at this, we'll explain you what is happening.
Sir, excuse me, we cannot
Yes, ma'am.
able to see the video, sir.
1 minute, ma'am.
It's only PPT mode.
Okay. So hope now it has been clear for you, right? I will click for this. Yeah. Yeah.
Sir, now also cannot able to see, sir.
Ma'am, it's visualizing now.
No, sir.
Yeah. I don't understand what is happening. Okay. So I'll explain, ma'am. It's no problem actually, right? I'll explain it. So what is the thing is, like, logic is in the video. What I've been showing it is, I unfortunately couldn't visualize it. Anyway, I'll explain you the logic, what is happening in the scene actually. So the scene which I've been explaining you is about, like, there was like a group of chitty robots. My explanation is going to be related with the film actually, right? So if you have a thing, like, if you can visualize it and you can see what is happening. The first thing is, you have to understand clearly, like, this is the scene. I'll explain you. There is a group of 100 robots, right? And from the 100 robots, what happens is, it has to differentiate, or it has to classify the human among the robots. This is the logic. Actually, this is the scene explains you. So here you can understand, you have a group of data, 100 data, right? And then you can have it like a logic. The output is now known. So you know the output is known, that it has to classify the scientist. That is, the human has to be identified and human has to be classified among the data. So now the output is known, and you have a group of inputs and you have a output is known. So now we are going to model the supervisory algorithm. Very simple. We are going to work the supervisory algorithm. So now what happens here? What makes the sense here? So now what happens here is, once the master calls over here, the chitty calls over here. So the chitty, like, what happens, the machine, what happens, it scans everything. It goes for a body scanning, and it goes for, like, it measures the breath, it measures, you see whether the sweat is there, and checks the body, and finally it finds out some feature, that is a rotation of head. So this is called feature extraction. So this is called feature extraction. When the body scanning is take place, out of 100 robot, it checks everything, but it not been shown in the film, but it checks for the 100 robots when it walks, where any human is present or not. So that is being done with the help of a feature extraction. So now let us assume a condition. If a chitty sits there and calls the one by one machine, and it checks one by one in manual manner, what happened to my time period? it will be a great, like it will be a real headache. So this is machine learning. So I repeat once again, we have an example. We've seen the example about supervisory where you have 100 robots and the output is fixed that it has to classify the human among the robot. So what happens here in the logic is you can understand clearly that when the robot, it scans everything, it takes the different features of a different robots. Now just understand clearly, Chitty sits there, calls the robot, takes each and everything in a paper and works it down and put up a code and see what is happening. So this is a real headache. So machine learning has the feature extraction to be done manually. This is the logic. This is the logic. So machine learning, we need the feature extraction to be done manually. But in the case of a film, we are visualizing it, it captures automatically. It segments the image. It goes it automatically. When the feature extraction is being integrated with that of my learning algorithm, that is deep learning. When the machine learning needs a manual calculation for all the feature and put it up on the code. But whenever in case of a deep learning algorithm, the feature extraction can be done by the training. So that's, we have a CNN. We'll talk about later on this. So this is the mechanism, how to make a differentiation. So feature extraction, extracting the features, putting up on the training, and do the output. And here the machine learning, we need to have the correct feature extraction methodology, because that feature extraction methodology plays an important role for learning and classification. So you have to be very clear about it. So we need to go for that correct feature extraction methodology, and then we can go for a output. So this is one. So when it is a separate blocks constitute your machine learning, whereas your deep learning, the feature extraction is a part. You can understand from this film actually. First one. Second one, I'll just explain you the choosing of a model based on this scene again, the second scene. So the second mechanism, what we are obtaining here is the phase problem is, phase problem is, we have the problem in the data. When you consider the scene, I'll explain once again, you have a group of data and the output is fixed. It is not that the data consists of 50% of a human and a 50% of your robot. This is not so in the scene. The scene very well clearly explains you that there is a similar kind of a data in which I have to differentiate the output. This is the headache, right? You can understand the problem in the data because we don't have the model. We don't have the differentiation of a data model here. We have group of similar data models. All the data are similar. And here the learning has to understand by itself, right, what makes the difference. So this is the very big headache on the logic. So how can I do this? How can I make this application? So here we make a classification. Again, I'll come to the mechanism. So how does my model works? This is very simple actually, like when you plot X and Y axis. So we'll take one by one. What the Chitty does, it takes the body scanning. It fails. We'll plot it.
Sir, we cannot, sir, excuse me.
Hello?
We cannot able to see the PPT, sir.
Ma'am, I didn't run the PPT actually. PPT is in static.
Okay.
So the logic here is very simple actually, like we have a scatter plot and you have, when you visualize the scene, the Chitty takes the robot, that Chitty takes the body scanning. It fails. That's a one feature. And the second feature, it measures your temperature. It measures your threat. It measures everything. It measures everything and puts up on your X and Y axis. But it couldn't find out. So the logic which comes into the picture here is find that is the rotation of the head. That is the distinct feature which makes us to understand, which makes the learning algorithm to understand this the robot or the human. So what happens is the human can't able to rotate the head for 360 degree, one. But robot can do it. So when you face it, you have this distant feature is separate from others. Once you draw the line over here, these two features are being line to line, will be adjacent to the lines. And this we'll call this in technical and a mathematical model, we call this a hyperplane. So this is the logic. And this whole model, we call this a support vector machine. And this is where the support vector machine has the highest performance, because it can able to learn or it can able to classify with the help of a single distinct features. So that is the support vector machine. So support vector machine, even though it is applied in image and everything, but remember, when you have a group of similar data on your board, if you have a group of similar data on your board, then we need to integrate SVM for the highest performance. So this is one kind of model, machine learning model. Hope you have understood it with an example of Chitty, where the Rajinikanth comes over here to explain it, right? So this is one kind of a thing where you have to understand the model, machine learning model. The second thing is choosing of a model. Again, I don't know how the video is going to be. Next, we have a second categorization. So what is the second categorization of the logic here is assume another scene from the robot. Let me play the video. Is it visualizing, ma'am? You can view it. Hope it is. Can see this actually. So this what I'm playing about the scene is, yeah. So this is again a supervisory. What I have played here is it is a scene where the machine has to rescue the people from the fire. So this is another second case study about choosing of your model. So what happens here in this model is, like, again, it works on supervisory model. So supervisory model is something like you have inputs is given and output is fixed right now. That is the rescue is to be applied. So what happens here, that for the rescue, it checks whether what is the output there to get the rescue. That is, it checks the magnetic focus, it makes the grill and everything to make it an output. So now what happens, how it selects it. So what happens, the main task of this robot is, it has the machine, you have to understand clearly, is it has to find out whether the human is alive or dead. If he is alive, he had to rescue us. Dead, it is not being shown, the condition is not being shown. So what happens here is, you have two options to solve this. One option is applying the conditional classes.
Sir,
Yes,
PPT we cannot able to see, sir.
Again a problem. Okay.
Sir, you can
Now
see the YouTube also, sir, because participants
Okay.
are commenting also. PPT not
Okay.
visible.
Is it right now?
No,
Now, ma'am?
no, sir.
1 minute. That's it. It's showing that it's sharing the screen. Now, ma'am? Is the screen is okay on the screen? Hello?
No, sir, screen is not visible.
Okay. Shows the screen is shared actually. Now it is not working,
No,
ma'am.
sir. No, sir. No, sir.
What is it? Now, ma'am?
No, sir. Sir, can you please go out and come back, connect again?
Yeah, I'll just go out and again and make it out. Now, ma'am? Hello?
Yes, sir. Yes, sir. Now it is coming.
Yeah, just Okay, just intimate me, ma'am. I'm not looking out the YouTube
Ah,
actually. Just intimate me. Just I'll come
okay,
out
sir.
and just join it, right?
Okay, sir.
Okay, so sorry for the interruption, guys. Right. So what we are talking about is uh, we are talking about a logic on the applying the conditional classes on the data. So what we are talking about is we are talking about the scene of a rescue system where you have all the alive systems, all the where we have to find out a person whether he is alive, and if he is alive, the rescue has to taken place. So how does it makes how does it decides whether the person is alive? So that is being taken care by the conditional classes. If I apply the conditional classes on the data, that is if he has a breath rate, if he has some voice, everything, if condition. So we are forming a trees on the data. So decision trees. So this is known to be your decision trees. So this is a second classification. And the third classification, what we come across here is something called applying the probability. Apply the probability on the data. So like we have whether he's alive or not, a chances of probability. When it is calculated based on the chances of probability, we called NB theorem, that is naive Bayes classifier. So you have a three categorization SVM, but like these two will have the efficiency, but if the data is missed out, if the data model is not been designed properly, what the problem arises, the accuracy misses out, the performance misses out. So you should be very cautious in handling the NB and that is your decision trees. So this is the third criteria. The fourth criteria, what I'm going to talk about today is something like this actually, right? So forget about this slide. Actually, you can visualize this slide actually, but I'm going to explain you what is the logic application number one. So you have a fourth category of your machine learning. So here we call this like, it's not a fourth category, it is a base for every machine learning algorithm. So that is artificial neural networks. So this is artificial neural network, and the artificial neural network is the base for a deep learning algorithm. It's a very base for the deep learning algorithm. Unless or otherwise, you can't able to find out what is the deep learning is. So now this is the logic. So this is the logic. This is the block diagram. So this is the first application of your video or image. What is this all about? I explain you the content, then we can design a model. So first thing is about here is what we are going to design is in the as well as we can relate with the COVID. So we have a facial recognition systems actually. You may aware about the facial recognition system, and the facial recognition system, it is normally utilized for the attendance and it is normally utilized for a human. But here, what is the logic which comes into the picture? What makes us to understand what is the logic which comes up on here is we are going to relate the facial emotions in respective to the symptoms of our body. So this is the hardcore topic. So we have to go for a facial emotions, emoting, that is we have a different emotions on the face. With that, we are going to relate with the concept of your logic called the symptoms of our human body. So this makes the sense of a logic. So how we can design a model. So before moving into a data model, and we'll just refresh it ANN and DNN with the basic examples. So artificial neural networks, it is something like it's a kind of a brain kind of a network. We have a brain inside, inputs and outputs are defined. So now you have in a model, we design an input layer, and then we need to have a output layer, and between there is a hidden layer, and all these are interconnected with a mathematical function, and you need to have a select and activation function which can able to propagate your data, that is input data, to my output layer. It is something like a blood which flows and carries your data to that. So these are the important points you have to remember for the artificial neural network. So here, what is the best example you can come across here is again a student's example. So again, you have a students and the output is fixed. The output, let us assume the students has to get 70%. So if the student fails to get the 70% based on the output, what happens here is we need to train again and again so that he get based on the 70, right? So what happens is I'm going to check the output. If the output is uptime, then no problem. If I don't get the output based on the input, I have to revert back to the hidden layer by again keeping the training so that I'm getting output. This is known to be your back propagation algorithm. And all your deep learning algorithm has been working on the back propagation. It has been working on the back propagation. So what is the advantage? You can see, like you can train it again until I achieve my output. But what is the major problem is, example, let me assume like we are writing an examination for the first attempt and we are not supposed to get the pass percentage. And again, we are writing it. So what happens? My brain will not be so fresh as you are attending for the first time. So this, what happens is in the back propagation, we have to revert back to the hidden layers, and we call this an output layer. There is a problem of gradient problem. There is a problem of a gradient problem. It's too mathematical actually. Please make it note of that. It is a gradient problem. So how to, if the gradient problem is there, the time consumption, everything increases. So nowadays, the deep learning or a neural networks, what we focused on is replacing this back propagation into a feed forward layer. So we are working on the feed forward layer. Okay, so we are working on the deep learning network with the feed forward layer. So feed forward, you don't have a back propagation, input and your output. This is one kind. And second thing is about, let me introduce a CNN here. That is, we have talked about neural networks, the convolution networks. What is the convolution network? As we talked about, it is a kind of a feature extraction. It's a kind of a feature extraction. So the convolution layer will have the convolution filters over here. And with the help of a filter, it can extract the each and every feature. Right? It can extract the each and every feature, and we can combine into a feature maps. And that can be utilized for training the machine. So now this is the case. So you have a CNN convolution networks where I can able to filter out each and every categories of my video or an image, and then we have a group of features. Group of features will be combined into a feature maps, and with the help of the feed forward layer, what I talked today will be combined to train it and get the output. So this is neural network. This is a deep learning network. Very simple. Here, hope you have understood what is this. Is again, third point is about we are in the hybridization of the algorithm. So what kind of hybridization of algorithm is required? So here we go. Here we go the block diagram here. We will go for the block diagram actually. So what is the block diagram is utilized here is, so here the second category after a deep learning, the CNN what we talked about, you have another category that is known to be your extreme learning machine, which is being integrated in the block diagram. It is an extreme learning machine. The extreme learning machine or a category of a neural network. It's not a deep learning. It's a category of a neural network, which is working on the single feed forward, that is feed forward mechanism. It works on a single feed forward. We have multiplier and single layer. It basically works on a feed forward. So now our algorithm, when you want to formulate a research for this kind of facial recognition, you can combine this convolution along with the ELM. So the training can be done in the ELM, and the convolution networks will be utilized to filter out the different feature maps. So you can integrate these two, and we were formulating it. This is where we are integrating or implementing the machine learning over the deep learning logic. So you have to understand clearly. This is where the logic which comes into that machine learning into the deep learning logic. So now I'll explain this block. So what happens here is, so we have to recognize the symptoms of the human body through facial emotions. So how can I make it out? How can, by seeing the face? It is possible by seeing the face, you can able to judge the people, right? So the logic which comes into here is, we are going to segment each and every part, right? Here, my CNN comes into the picture. So I just repeat you, segmentation, multi-segmented facial features. These two blocks can be combined or can be done with the help of my CNN convolution networks actually. So what it does actually, so what I'm going to do is, in order to read this kind of data model, in order to extract this kind of a data model, you need to refer a book or a website or a coding standard system which is available. That is called FACS, that is facial action coding system. So the facial action coding system is important because what it happens there is, we have a different emotions is being related with the different people. So this is the logic. So different, you can imagine there is a different emotions related with the different people. That is, it covers the subcontinent of all the continents of the world. So like you can combine these two. There is a code. If he is a man getting angry or man getting like what happiness, what is the node? And one, if he gets a pain in the body, what is the node? So everything is there. Now we are in the process. We have to, after extracting the each and every part of our face, we have to make a coding system, the input coding system. And the problem is CNN we have utilized, and we have combined, as we discussed, I have combined with the extreme learning machine, because extreme learning machine will provide you a lot of stuff for a lot of stuff and high accuracy when compared to the SVM what I talked today. So like you have an extreme learning machine. So now the model is ready right now. So the feature extraction from the each and every feature of our face has to be extracted related with the FACS, facial action coding system, and we need to relate with the symptom, that the new FACS system has to be formulated with the help of your learning algorithm. this also can be utilized to validate your mechanism. You can able to combine this with your body signals. You can combine with the body signal. So if you have a symptom, suppose for example, if he doesn't like anything, his face reaction is different, but it can be same with the help of your, it can be same for all the disease also. So any abnormality in the body also. So the body parameters are also be like interfaced. So here you have to understand it's a fusion of the images and the signals. So n into n into n. That is, you have a three-dimensional data. So we are fusing it for this logic, and this fusing of data is utilized for the classification. This is where I'm stressing you guys. We have to work on this. That is a multiple fusion data model. So this can be validated by interfacing with any kind of a body signal. Either it may be a ECG or EEG. But the accuracy remains. You can put up me a question whether there is accuracy is higher or low. It is low actually. It is less than 60%. We have got only about 50 to 55%, but we are in the process of improvisation, because in this COVID area, and that is in the COVID scenario, we are in the process of developing a non-invasive. So this kind of a technology can be utilized with the help of AI. So I have formulated a new algorithm, CNN, with the integration of your extreme learning machine. This is kind of a facial mechanisms. Other than the facial recognition, everything you can work on with a symptom analysis. So as like in the sentimental analysis, we can work on the symptom analysis from the different faces. So different, not a different faces, a single faces. Like this is one kind of application when the body is required. So the second kind, what I'm going to talk about is voice. So this is the logic what we come across in the voice processing. I'll explain you the scene of voice processing over here. So the voice processing, what happens in the voice processing is, so something you can see this in the voice processing block diagram. I'll explain you with an example. I'll explain you with a simple example of your voice processing. So you would have seen that in the film of Endiran, you would have seen that what do you say, like in the film of Endiran, there will be a kind of a logic, there will be a kind of a mechanism of the conversation between a policeman and the robot. And the policeman says you like it is a station, and the robot machine answers this, which kind of a station is, whether it is a police station, railway station, or a radio station, what are the station? It confuses. So this is the major problem. Hope you have understood the scene. Actually, there is a conversation between the, what you said, there's a policeman and the machine, and the policeman questions with the concept of a station, come to the station. And there is a confusion in the machine that which station it belongs to, because you have different categories of stations here. So this, I'll explain you how it has been done. So whenever you are working with a voice processing, and today's media, you would have seen some interesting article on Indian Express, if I'm so Indian Express or Hindu. There is the corona or COVID can be transmitted through voices, right? So transmitted through voices, through the speech, everything. So there is a scenario in the paper, right? So what it can be done with that? So forget about this. We'll talk about this, how the machine understands and what is the advantage of this actually. So when you have a book, or when you have a kind of a book to be understood by the machine, and when you have a voice, a group of voice to be understood by the machine, first thing about what you're seeing is about knowledge extraction. You need to extract the knowledge from the
sir, excuse me.
Yes,
please put in the presentation mode, sir.
1 minute, ma'am.
This layer is called.
So what happens here is, 1 minute, I'll just explain you, and then we can go for a presentation mode. I'll explain you again. We can go for a presentation mode right now. Okay, so the logic which comes into the picture here is yeah, hope it is now it's audible, right? So the logic which comes into the picture here is this actually. So here is the model which we have the concepts of here. So what is there is, you have a station, and I told you it has to confuse, the machine confuses over here. When you have the voice processing and the voice logics over here, when you have the group of document and the voices, how the machine understands. The first part which comes over here is the knowledge extraction. So this is why it has to extract the different words that we called as a bag of words. We call this as a bag of words. So what is the algorithm which is being utilized here is, there we integrate a model called BERT, B-E-R-T. It is the BERT model from the Google architecture, where you can do with a lot of applications on the voices and the extraction of words. We call this as a bag of words. It is known to be your bag of words. So it extracts, the BERT model is integrated. and for example, let us assume the scene there, it established the relationship. So what happens is the station is the word which is extracted by the machine. Now you think about in such a manner, the machine and wants to understand that it belongs to the police station. So you should assume that it is a police station, and the police and the station will be extracted differently. Now we are in the process of developing a relationship between the station and the police so that it can formulate a new word. So this kind of relationship is being done with the help of knowledge graphs. So this is being done with the help of your concept called the knowledge graph. And that knowledge graph is done by the mechanism called semantic relationship. Semantic, I repeat you, SEMANTIC, semantic relationship. So we call the semantic clustering. So what happens here is the noun and verb and everything will be extracted, and it will be formulated as a graphs where you can formulate a sentences, group of sentences. You can formulate it as group of sentences, and these sentences are now utilized for a training process. And what happens here is, this is the logic, it trains everything. You can implement a reinforcement here. Nowadays it has been integrated with the reinforcement for the training for updation of words. But now the picture has been given, a picture has reached that it will be integrating a self-learning adaptive, the self-adaptive learning algorithm, what I talked on the starting of my session. It has been integrated with a self-adaptive learning algorithm. What it actually belongs to, for example, when you are just seeing the video, when you are seeing a document, first book, let us assume it refers to your cooking book. You have all the words, established everything, semantic clustering, programming, everything is done. Based on that done, we are just training it. My database is ready. Now sentence is ready. My machine can understand that book. But if I show the second book, right? Assume you are showing the second book. So what happens in the second book is like the sum of the words needs to update it. So it needs to update itself with the new words. So that kind is being done with a self-adaptive. So the new words, it finds out which training is missed out. It finds out the new words, and by the new words, it trains again and it backs to it. If the word is repeating over in the first case, it discards it and coming to the next level. So this is how the training process will taking place. This is something most advanced model which is being designing today. And you can design it with the help of the, not only for the speech, it can be utilized for an OCR, optical character recognition, from which where you can learn that the 12th, even from the 12th century or even the first century letters can be recognized with the day-to-day devices what we have today. So this technology, that's this kind of algorithm you can utilize for this kind of application. That is making the device to understand with a document, with the books, making the machine to self-readable by itself. Second thing is it can understand the voices, because this plays an important role in designing a language model and everything. Third thing is about it is normally utilized for OCR, that is recognizing the very old characteristics and bringing back today's world. And the fourth important point what I want to discuss with is about this application is, we have talked about self-learning and reinforcement, but in today's world we are utilizing an algorithm, a deep learning algorithm, that is called LSTM, long short-term memory. Long short-term memory is being utilized here for the voice processing, along with that of a knowledge graph what I told you, right? But today again an LSTM is now replaced with another technology that is called masked LSTM. Sorry, masked is MASKED, masked LSTM. And fourth point, again another technology that is known, another algorithm, sorry, it is transformer neural network. So this is another category, that is a transformer neural network, which is another new category which finds its place on the speech processing. So these two algorithms plays an important role along with the BERT, with the process of extracting, with the training and everything. So please remember guys, we have talked about one CNN and ELM on face, and now the in the voice and the document, even particularly on the voice, we are concentrating on the self-learning. And nowadays the LSTM is now replaced with masked, and now the masked is now replaced with a kind of your what we called as the transformer neural network. So you have another category, that is a transformer neural network, which plays a very important role for the kind of a subdivisions. This is all about your voice processing. So you can use this model, and everything is on Python, so you can use this model. So third category, what I'm going to talk about is this. So this is another application what we have today. Third application. So we talked about voice, we talked about images, and the research problem we have come across is this. This is the problem. This is the problem. We have like video analytics over the network, IoT network, Internet of Things network. So what this model represents, I'll have an example of your scene. Again, in a chitty, in a robot film, you would have seen it. Please, I cannot make it a playing of a video. You can, if you have a time, please serve it of the nets, serve it on the Google, like what are the scenes I'm just explaining you. So you have a interval block, pre-interval block scene in a film called Endiran, where the robot does the delivery. It does all the kinds of hospital management system and everything. In that one particular scene, you can visualize the machine captures the data, that is video, ultrasound video, and it transmits over all the Wi-Fi network. So this is the logic. So this is the logic where the IoT gets into the different scenario. So what happens is the video is being captured, and like ultrasound video, that is ultrasound medical video, will have will consume large number of bandwidth. So in that scene, you can able to visualize everybody who is entering into the scene can able to visualize, who is having the Wi-Fi can able to visualize that particular fetus problem, that is fetus position. Here, what is my question? What is my problem here is, what is the logic here comes into the picture is, since it consumes larger bandwidth, so you like the IoT has to be made clear that it has to serve to transmit that it's all medical video, it has to be transmit correctly. And as the number of users increases, like as in the case of here itself, we are facing a lot of problem. So here, how does my artificial intelligence and what kind of algorithm can be utilized to serve this? So this is the block diagram of the film. We have taken a case study, third case study from the film, that it is the block diagram. I don't think that this is the block diagram is integrated, but we have converted this scene into this block diagram. So just please look at this block diagram here. You have original video sequences, and in that film, they will have the MPEG compression, and instead I'm just going for encoding, that is again a H2.64. And what happens here is, I'm just taking the bit rates here. You can take out the bit rates normally. We are taking a bit rates. And second thing is about, we are taking about the content. What is the content is, when you see the ultrasound videos, when you concentrate on the video mechanism, everything is converted into frames, right? In the frame, we have to take care about a lot of logic. That is, what is the slow motion, fast motion, medium motion, every motion has to be taken care. And we have a separate technology for that. So this is the content, okay? So content and all these two things. And the third part, I'm just combining with the network characteristics. If you are using an IoT characteristics, or if you are using a 4G or a 5G network, you can very well assume that it will have a RSSI, signal strength, distance, channel, and even link quality indicator, everything. So all these things is being combined into a data set. So all this combined. So what is the content? What is the characteristics of the network and image? Everything is put up in a data set. And as you know, that data, that is IoT, requires a gateway. We are in the process of designing an intelligent gateway. So what kind of thing you can integrate here is the intelligent. What intelligence? So now my gateway transmits each and every frame in accordance with a network type, right? Or a network type or a network characteristics. If the signal is high, what happens here is, with the high signal strength, I can able to send the most important frame of my video. Very simple. If the strength is less, what kind of video you can select it? That can be done with the gateway. And this is the logic which combines your video frames with the respective to the network characteristics. So the IoT turns into another dimensional one. It has been combined, it has been turned into another dimensional one. We have group of data, group of videos over here. And the video, it has to take, how far it has to take about it. It has to take, it extracts and put it up in the data set. And finally, it has to decode it. And the receiver side, there is a decoding where you can see all the videos simultaneously. So what kind of algorithm, what kind of integration of algorithm you can visualize here is, here we can integrate a CNN, convolution neural network, along with the machine learning logic, optimized machine learning logic. This is another criteria what we have as a machine learning category of machine learning, that is, it is optimized machine learning algorithm. So optimized into X. The X can be any category. It may be SVM, it may be what we talked about, ELM, anything. So this is the X optimized category. What do you mean by optimized? What is the logic in optimized? So what happens here is, let me have another example. Again, a student example. What we do is, instead of like training them with because the problem what we face in the model of a neural network is fixing up the hidden neurons is something, it's a very big headache for us. We would have faced it when you was drawing it. Actually, what we are suggesting it, we can integrate some optimization algorithms such as meta-historical algorithms, such as a BAT algorithm, or even ACO and colony optimization algorithm, even genetic algorithm. So these algorithms is used to fix your neurons according to the accuracy to be obtained. So this is the model, right? This is the model, another model what we have. So you can fix up this and you can do the logics. So this optimized machine learning, I hope you have understood. That is the problem what we come across here is, the problem is very simple. That is, the fixing up the neural network is a real nightmare. So real challenge. So we have to put up all this trial and error methodology. We don't have a formula. So in order to make it out, just I fix up, another layer comes into the picture, that is optimization layer. Even though the optimization is required in the data, but here the optimization is required for fixing up my neuron according to my accuracy. This is known to be optimized learning algorithm. So here you can combine three different algorithms. One is with the CNN trained by the optimized learning algorithm. So this is a thing, because you need a power because it has to be integrated on the hardware. So we cannot able to trial and error method. So we are fixing up everything on the hardware. So this comes into the picture. This is the most important scenario where artificial intelligence, or it has been combined in terms of a IoT, when the IoT is utilized for the video analytics or the gathering of a video data system. So this is one kind of third application where the AI plays a vital role. So fourth important thing is, how do I practice on all these things? So we never talked about this sensor network. Actually, I just give a word of a sensor network, fourth application, and then I'll come to the tool. What are the tools you have to do it? So first thing is about, when you work on the sensor network, there is one important area, not only in sensor network, any network area, we have one particular thing that is called security breaches, security flaws. Because when IoT comes into picture and everything comes into the picture, for the networking of device comes into the picture, you can understand that it will have lot of security flaws. So how can my AI plays an important role? So here we are integrating a new algorithm of AI, new dimension of AI, that is called as chaotic artificial intelligence. It's chaotic, right? Chaos, we know it's a chaos. It's a chaotic artificial intelligence algorithms. Something, it's very new to the field of encryption and decryption. We have a lot of encryption, hybrid encryption and everything. But the impact of artificial intelligence on this network security, we have the term called the chaotic artificial intelligence. So this may take another 3 or 4 days to cover. This is a huge topic actually. Okay. So chaotic. So please make a word of remembrance. Actually, it is chaotic artificial intelligence. So in sensor network or in IoT or industry 4.0 or anything, or a band network, whenever you want to work on a kind of a security breaches, when you want to overcome the security breaches with a kind of artificial intelligence, you can utilize this kind of a network, this kind of algorithm, that is chaos combined with the intelligence algorithm. So this is something new, and it is trending in today's world, in the world of encryption, right? So generating, and why this chaos, I just give a word where the chaos is derived. It is the base for a quantum. So you heard about the word called quantum computers, quantum algorithms and everything. This chaos is the word, is a base for your quantum. So this is about this. I'm just combining all these things, integrating all the algorithms in a single one. So this is about the fourth application of WSN. Whenever you want to apply the WSN, or when you want to apply any kind of networking over the security breaches, you can use this algorithm, chaotic artificial intelligence, for a better understandability, right? So this is the fourth application. So fourth application where you can design a model. The fifth thing is, how do I integrate, sir? What I want to integrate it, what I want to integrate. You are seeing this kind of application. Where do I integrate this? So to start with this application, please, you have different options right now. So how to work on this? Working on this is something like, we have real-time scenario and experimental scenario. Experimental scenario, what we are working today. That is like taking a general data set. For example, if it is a COVID, we are working on the general data set and working on the scenario of each and everything and putting up on a classification. But my point is, in order to, if we are working, it's well and good. But if you can work on with the real-time data, real-time examples, what we talked about today. So if you can take up a real-time problems, right? So that real-time problems you can able to visualize in with the help of general hardware. Please make it on the hardware sector. And the hardware, what I suggest you is NVIDIA Jetson Nano, right? So it's a NVIDIA Jetson Nano board where it has been like playing an important application today's world. So it has been generally it works on Python, and you can also write an C API also. And all the APIs for Python for deep learning, such as TensorFlow, PyTorch, can be integrated in the Jetson Nano board. So you can utilize, if I'm designing a gateway, I cannot sit on the system and design it. I need a real-time hardware stuff, the deploying all my model on the hardware. That can be done with the help of NVIDIA Jetson Nano board. So you can utilize that board. With the help of that, you can able to do a lot of application. As far as the programming is concerned, everybody knows it's a Python actually, which is normally happening here. But Python may have a replacement with the help of Go programming, Go programming from Google actually, or it is like it is coming up. No problem. Like I don't know, like whether it will take a time or not, but it will take some time to replace it. So I'll just tell you the future. That is Go programming will come into the picture for next or 3 to 5 years for the machine learning algorithm, because the Go is something like a C programming. So you have a C concepts, and if you can do with the C logic, it is very easy actually, right? So this is the Python, and nowadays we go for the Go programming for all kind of stuffs over the logic. So this is how it is going to the deployment. Please have the data sets. What I told you, first start with the experimental data sets. Model, I have listed out with some of the model selection, but you should be very cautious about designing a model. And I have told you some of the hybrid algorithms also, which can be utilized for each and everything. So please concentrate on this so that you can happen in all sort of applications. So finally, what is the logic? Finally, like what is the thing I want to make you is, please, if you have been very particular about it, please work on the sentimental analysis, which is requiring today's world, based on everybody is working on the views, right? Reviews of every product, but that is not so. We have another side in which the sentimental analysis it is utilized. It is utilized to make understand the behavior of the particular persons. This is badly required today. So sentimental analysis, how can it is utilized to understand the human behavior of the person? So that has to be done today, because we are facing a lot of problem in the Twitter, we are facing in FBs, and even in the WhatsApp, every security is being like flushed about. So this is kind of a research you can concentrate, other than the COVID, you can concentrate on this area based on the algorithms. What I told is very simple. It's common for everything. So this is how this application over here is ended right now. So hope you have understood all the things what I discussed it with some real-time example. Unfortunately, I couldn't see. I can make it a video. So hope you have understood the basics things and everything. So if you have any queries, please make a post queries on that, so that I can answer you for everything and I can support you for the everything. So thank you for every thing. Hopefully you have learned something else. It's an eye-opening program. Hope you have learned something else. So best wishes for the research which coming out, which our country badly needs. Thank you, ma'am.
Thank you, sir. Sir, we have some question answer from the participants. Can I ask, sir?
Hello.
Sir, can I ask, sir?
Hello.
Sir, can you?
Hello.
Sir, can you hear me?
Data in which I have to differentiate. So hope that you have feedback session, right? Kindly fill up your feedbacks, and it will be closed by 6:10.
Hello, sir.
Kindly fill up your feedback, and it will be. Hello. 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 Hello.
Sir, hello.
Yes, ma'am.
Sir, now you can able to hear me.
Yeah. Yes, ma'am.
Sir, we have some questions, sir, from the participants.
Please, ma'am.
One question is from Bose Babu. Give some recent research deep learning algorithms that is to be used in an application implementation.
Yes. The first question, like I have told already, that is a hybridization of machine learning over the deep learning algorithm. So I told you, like, deep learning will consist of each and everything. Let us assume we work on the image data sets. So you have a CNN, and the CNN is being now combined with the logic of your neural network. So I told you, like, nowadays the neural network works on the back propagation algorithm. So you can take this back propagation algorithm and replace with the help of different machine learning. For example, you can integrate with the feed forward, which is currently, you can check it out with the 2020 papers. You have a feed forward network is playing a vital role in case of a backpropagation. So feed forward layer along with the convolution network, you can combine these two and you can formulate a new algorithm for the video and your voice, for your image mechanism. For a COVID, like for example, like you have a lung data set and everything, you can integrate these two for the images and the video. And my suggestion is you can go for the hybrid integration of all the algorithm, that is hybrid integration of your machine learning over your deep learning algorithm, so that it can formulate the better performances than the existing one.
So thank you, sir.
Yes,
So
ma'am.
one more question, we can wind up the session, sir.
Please.
What is the difference between robot design with AI technology?
So the difference is not there actually. The robot technology needs a mechanical design and everything, because the kinematics and everything is to be designed properly. But the logic which comes into the artificial intelligence is, in order to make it work on that, we need a software. We need a hardcore software, that is the intelligence software which is required. So that intelligence software will be imparted on my CPUs. We have large number of CPUs which is available right now. And that software can be integrated on that CPU and it is utilized to control my machines. So this is where the robotics needs intelligence. If you design a robot, it's a mechanical part. It's a simple like a human without a knowledge. The knowledge is required for the robot to understand what is happening. This is what I'm talking about, all this algorithm. So there makes the difference. So when you talk about only artificial intelligence, is something like designing a model with a different kind of input, output recognition and everything. But in case of the second, when you integrate in a robot, it makes the machine to work. So that deployment is required. So that makes the difference for these two. So this is the difference and this is the logic.
Thank you, sir. Thank you for your valuable speech, sir. It was an excellent talk. Actually, practically, we learned many things, sir.
Thank you.
Thank you so much, sir.
Thank you, guys. Yeah.
I thank our head of the department, Dr. A. Vimla Juliet, ma'am. Then I thank all the participants for your valuable presence. We will be circulating the